We are closing in on our completion of the Hurricane. The next steps are to get the frets levelled and dressed, the cavities shielded and wired up, do something with our finish, and then get the whole thing set up and ready to play. Let's start with the cavity shielding then. I'm using this adhesive copper sheet to line the control and pickup cavities. It's a fairly simple process of measuring the dimensions of the floor and walls, cutting the sections to size, and then sticking them down into the cavity. This creates a Faraday cage. By enclosing our electronics in a conductive box, we prevent any radio frequency interference or electromagnetic fields from reaching the interior components. Proper shielding in this way can pretty much kill hum and other unwanted audio effects our guitars may experience while surrounded by amps, lights, and transmissions from radio, Wi-Fi, and other generators of electromagnetic radiation. The original electronics for the Hurricane consisted of a volume and tone pot, and 3 on-off-on double-pole, double-throw switches. The switches allowed for each pickup to either be off entirely or in one of 2 other active states. This allows for a colossal 27 different tonal combinations. Well, in reality 26, as one of those switch combinations is everything turned off. I'm going to upgrade to new electronics as I can't guarantee the exact quality of these old parts. The original pots were rated at 250 kiloohms, which is a great rating for guitars with single coil pickups. With the new stacking humbucker, however, I'm changing these to 500 kiloohms. The difference in the value of the pots is to attenuate high-end frequencies. The single coils are naturally more bright, so using a lower rated pot stops them being too piercing. On a darker humbucker, however, 250k might be choking a little too much, so 500k is regularly used to brighten it up. In a guitar like this where we have both humbuckers and single coils, it's always going to be a bit of a compromise what pot values to choose. I'm using these Alpha brand pots this time round. I usually use CTS, but I thought I'd give these Alpha ones a go and see what they're like. They aren't quite as smooth to turn as the CTS ones are. If you're a set and forget kind of player, then that won't bother you too much, but for someone like me who's always on the controls, I think the CTS brand pots can't really be beaten. The tone cap that I'm using for this one is a Cornell Dublier Orange Drop. You might be more familiar with the previous manufacturer Sprague, who sold the Orange Drop line to CDE in 2012. These are the tone cap of choice for many manufacturers because of their incredible stability and reliability. These things were originally designed for use in military electronics, so needed to be able to handle changes in temperature and humidity, as well as high voltages and resistance to microphonics. The truths and myths of tone capacitors is definitely a whole topic unto itself to be discussed at some later point, but these Orange Drops have a really good track record and are very worth investing in. What I'm going for this time round is to have both humbuckers, the bridge and neck, to be switchable in either series or parallel. Series switching is the standard way of wiring up a humbucker, allowing the resistances of both the coils to add together. Parallel wiring, on the other hand, allows for the inverses of the resistances of the coils to add together. This gives us less output, more like a single coil sound, but unlike coil splitting, we're still keeping both the coils together, so we're still having a humbucking effect. It's a way of getting a single coil style sound without removing the humbucking quality of the humbucker. The middle single coil will be wired so you can switch it in or out of phase with the other pickups, which will lead to some very interesting thin sounds. Of course, all this loom will have to be removed before I do the finish, but I just wanted to show you the kind of wiring we'll be doing right now. Preparing the frets properly to be played on is very important. Firstly, I'm going to flush up the ends with this fret leveler and then add bevels to the frets. This will make the frets much more comfortable to play, so that we're not coming to an abrupt 90-degree stop at the edge of the fretboard. I don't have a precise angle I bevel these to. I eyeball it and see what looks and feels right, and then make sure both sides are the same. After this, the edges will still be sharp. This tiny file is a fret end dressing file. It allows me to roll over the sharp edges on the bevel and leave a nice rounded slope on all of the frets. The file itself has a rounded bottom edge so that it doesn't bite into the fretboard. While these new frets have been installed in a consistent manner on a fretboard we prepared to be smooth, we can't guarantee that all the frets will be at the same height. This is true for frets on most replacement necks or kit guitar necks. Some fretwork will still be required. So I'm masking off all the exposed fretboard. This will both protect it and allow me to mark places where frets might be high. This blue permanent marker I'm drawing on the tops of the frets will act as a guide when I begin levelling. We'll be able to see how much of the fret has been removed and very easily see if any frets are levelling faster than others. With these fresh frets, it should only take a very light pass with the leveller to bring everything into line. I can check afterwards with the fret rocker to ensure that there are no frets sitting higher than others. At this point, I often like to layer some tape onto the 12th fret and level the upper frets just slightly more. This section of the board is more prone to fret buzz and notes choking out when surrounding frets, so taking them down just slightly further works to eliminate that. Another way to level frets if you know the radius of the fretboard is consistent is to use sandpaper on a radius block like I'm doing here. Now that everything is at the right level, I can again blue the flattened fret tops and prepare for recrowning. This triangular file will allow me to re-establish the rounded tops of the frets, leaving only a very narrow blue line in the centre to act as our new fret top. There's a bit of skill to this, but mostly it's about controlling the angle of each file stroke to achieve perfect roundness. Any rough file marks still on the narrow tops can be addressed with a sanding stick, and I like to take a light pass over the whole fretboard with some sandpaper like so, just to make sure everything is smoothed out. Now these frets need to be polished to make them super smooth for best shred-worthy action. I'll start the process with these fret erasers. It's a rubber with an abrasive grit throughout it. These will conform to the shape of the fret while polishing up the surface. I go through all the grits in sequence and then move on to these polishing pads. Same rules apply here, they conform to the shape. Working through the grits polishes the frets up, and by the time I'm at the last pad, we have some very shiny frets that are more than ready to be played on. Looking at the body, we need to do something with the finish. Swirl Dip failed last time, and I'm unsure if I want to try that again. I will need to repaint certain areas to cover the now exposed sections, and I want to keep the pink colour where possible. I also have a whole range of brightly coloured Sharpies, including some neon ones. I've seen some hand-drawn artwork on guitars before, and it looks pretty cool, so I'm wondering if I can't do something the same here if I hit the areas with white primer first. While I do some final sanding to all these surfaces in preparation for whatever finish I decide to do, why don't you leave a comment below with interesting finishing suggestions for me to try. That's all for this time though. Don't forget and subscribe for more content. Check out Patreon if you want to access some exclusive secret stuff. Social media links will be in the description, and as always, keep it loud, and I'll see you later.